Hello, my name is James. I'm a Femap Specialist here at Saratech, and today I'm going to be demonstrating how to use a 3D arbitrary data surface for applying external loads such as temperature and pressures. In this example, we're going to be using temperatures though. Most likely you'll be getting these loads from like an external CFD analysis. So let's take a look at our data here. What I have is a bunch of point data. It's given an XYZ position and a scalar value. In this particular case, it is temperatures. These should be in Fahrenheit. So what we're going to do is copy and select all this data. We're going to put this just in the clipboard to make it easy once we get to pasting it into Femap. So we're going to hit Control-C here, and now I've copied all this into our clipboard. Let's go over here and make a data surface. There's a few different ways to get it. I've got it pinned over here, and then you can also get over and turn that on to Tools. Data Surface Editor, for example. So let's go in our Data Surface Editor here. Drop down here. We want Arbitrary 3D Data Surface. This one allows us to apply point data. And I'll just hit Paste here. And we can see that all that data that I had copied to clipboard has now been pasted. Again, it's just XYZ location and a scalar value. I'm going to give this a name. Data. Okay, and I like to mess around with this options. I think the interpolation process is a bit generous in the number of points it grabs. So I'm going to change this to 1 and minimum locations to 1. Coincidentally, because I use this model to build the thermal data and export it out to then be able to import it in, my nodal locations or my point data matches pretty exactly here on our model. We can see wherever we click, we can see a little plus sign right here showing us where that particular data is at. As you can see, it does match up pretty exactly with my model because it was exactly the same model. Let's go ahead and click OK here. So now in my data surface, we can pin this just for a moment. We can take a quick look at all our data here. Doesn't really matter. We don't need to really modify with this at the moment. If we do find that we have some particular issues with our data, we can always go back here and correct it. And one thing I'd like to point out here is that our orientation of our model must match the orientation of the data that we're importing in. So if that model is in a different coordinate system and a different location on that, we're going to want to make sure that everything's been modified, either modifying our point data or modifying the location of our model to match that of our point data. Let's go ahead and unpin this. We're back to here. Let's go ahead and apply our loads. I've got a load set here already called external temp, and we're going to do our load definition. That's going to be nodal here. We're going to select all. In my particular case, you may not necessarily need to do that in your model, especially with pressures. You may only be applying them to specific surfaces. All right, so now we got our temperatures here. It's already set for temperature, and I'm just going to put a unit value 1. What's going to happen is this value is going to be multiplied by the value in our data surface, and since we don't want the data surface value to change, since that happens to be our magnitudes for those nodes, we want that to stay at 1, or stay at that value, so we're going to be multiplied by 1. We'll change our data surface here, our method to data surface, and from the drop down we should now see our data surface available. We click OK, and there we go. It's been applied. Now it might be a bit difficult to verify that our data surface is interpolated properly and that everything looks appropriately, because if we look at this, this might be a bit hard to read in much more complex models, but I can simply see that the 70 degrees Fahrenheit that I fixed on this end when I ran my analysis does match. And I'm assuming that this matches with the model, but there's an easier way to visualize this versus just manually look at these numbers, especially if it gets more complex. Let's go hide that. And let's go over to Model, Output from Load. From Load. Oh, I don't have an output set yet, so we'll give this a output set name. We'll call this valid. Give that a name, validation of thermal load, click OK. And so right now it's going to select the type of individual thermal loads. So for temperatures, it's going to be nodal temperature load. If this was pressures, for example, from a CFD analysis, For fluid flow, we'd select that right there. We'll just go ahead and click OK. And it's created this, we can see in the message window, it's created an output vector 24-ish, very big number. So we'll be able to go into our results here, and we can see we've got this new result vector here, or output set. And then if we turn on our contour, we should be able to select that, and let's go ahead and select our vector, select that and go OK. And now we've got a nice quick visualization of our temperature results. I can see here we've got 70. We can see this nice even distribution up to 191, which matches the thermal analysis I did before, where a heat flux was applied on this end and we had the fixed temperature here of 70. So everything's looking good. So at this point we have now applied our temperature loads. We should be able to just run the analysis. We're going to go over here and just run a standard static analysis. And there we go. It has completed. Let's close this out. Let's go back to post-processing. Let's change this to this, our results. Obviously, let's get our total translation. It's not going to show us much. Remember, both ends are fixed. What we're really going to see is stress. Take a look at those solid von Mises stress. All right, so we are getting some thermal-based stress results. We're going to have some peaks around here because these nodes are fixed. So this node's not allowed to expand outward at all. So that's why we see more of a peak there. If this was a bit more free, we had this edges, the end here, able to expand, we would see that. We would see more expansion there. So yeah, you can see that in their exaggerated displacements, how these faces are fixed and therefore not able to expand in our exaggerated stress. We can see we're getting more thermal expansion here over on the hotter end, which is beautiful here. All right, so that concludes our demonstration here on how to set up a 3D arbitrary data surface. Thank you.